Hey, hi folks, my name is Akash, and today in this particular video, we will be continuing our part 2 of day 4 series. Okay, all right. So, we'll be going to understand about what are the encoders basically, what does that mean, what are the encoders, how we will be approaching, and how we will be going to tell them specifically. Okay, so that makes a major impact and how you will going to represent that basically. All right, so first we'll understand the particular what the encoders autoencoder is all about, how you will be going to tell to the recruiter or all the sort of stuffs. Let me know. Okay, how is that, like we will take a one by one question, make a like small kind of a videos that helps for you, or like how is it? Okay, so I'm just testing like how if it is shoots you well, so we can go through that approach itself. So I will be not making long video, and so that it will makes an impact, so you will understand what's the sort of stuff is all about. All right, so let's get started. What are the autoencoders about? And we'll go to understand about what are autoencoders basically. So autoencoder is a neural network that has three layers basically: input hidden, which is also known as encoding layer and decoding layer. Okay, this network is trained to construct its input, nothing but a features that you want to construct, which forces the hidden layer to try to learn good representation of their inputs basically. All right, so this is all about the autoencoders they are talking about. Okay, so now what is an autoencoder is an unsupervised machine learning algorithm that applies the back propagation, setting the target values to be equal to the inputs. An autoencoder is a trained to attempt to copy the inputs to its outputs. Okay. Internally, it has a hidden layer which describes the code used to represent the input. Okay. So take an example like this. Okay, you have given the two original input. It will send to the encoder. Then it will be going to compress the representation, and it will decode, and it will recognize that whatever input that you have given, that is to itself. Okay. So autoencoder components consist of four main parts: encoders. In this, the model learns how to reduce the input dimension and compress the input data into the encoded representation. Number one. Number two, the bottleneck in this layer contains a compressed representation of input data. This is lowest possible dimension of input data. Decoder in this model learns how to reconstruct the data from the encoded represented to be as close as the original input as possible. Okay, then it will reconstruct the loss. In this method, what it will do is measure how well the decoder is performing and how close the output is related to original output. All right, so there are types of encoder like denoising the auto encoder, sparse the auto encoder, variation or auto encoder, and contractive auto encoder. All right. So this is a particular like what are the encoders and what are the components is all about. So number one, how will you represent to that to the recruiter, and how you will understand that basically autoencoder, right? What are autoencoders? Autoencoder has three layer: input layer, decoding layer, and hidden layer, right? So input layer is hidden layer, which is known as encoding layer. Decoding layer, the network is trained, which is reconstruct the outputs. Hidden layer is try to learn the good representation of inputs. So likewise, the same thing you have to do it. So for encoder, what it will do, the model learns how to reduce the input dimensions, just like that ways, folks. So you can just write it like this: autoencoder components. It has four main parts. Four main parts is first main part is encoder. Okay, so I will just put it like this: encoder, bottleneck, decoder, and reconstruction loss. Then this encoder, what it will do in this model, learns how to reduce the input dimension, compress the input data into the encoded representation. All right. Then Bottleneck, what it will do, like representation of input data. This is lowest possible input dimension of input data. Decoder, what it will do, model learns how to construct the data, encode the representation to be close to the original input as possible. Okay, so I am just I'm this is the last video of this particular series, folks. I'm not saying each and everyone is commenting in the video description, folks. Okay, I'm making a video for you, folks. So let me know in comment down below. This is helping you or helping you guys. If I get lot of the things, lot of comments, lot of DMs, if I'm reaching, so then I will be continuing this series. Otherwise I'm stopping this series, and in the next series I am going to continue another kind of concepts that was related to the tech, basically. Okay, so let me know in comment down below, folks. I will be just continuing this. I will be completing this kind of questions now. They will be asking what is a CNN. So this is a simple application of filter to an input that results in an inactivation. Repeated application of same filter to input results in map of activation called feature maps, indicating the location and the extent of the detected feature in input such as image. Okay, so basically, convolution neural network is used for image classification, basically. So it is a major building blocks which are used in convolution neural network. This connets is a sequence of layers. Every layer transforms one volume to another through differential functions. Different types of layers in CNNs are. Let's take an example of running a nets. So, nets of a image of dimension 32 by 32 cross 33. Okay, input layer, it has a raw input of image with width 32, height 32, and depth 3. Okay, convolution layer, it computes the output volume by computing the dot products between all filter and image patches. Suppose we use 12 filters of this layer, we'll get an output volume of dimension 32 by 32 with the 12 things. Okay, so activation function layer, what it will do, it will element wise, it will perform the activation function to the output of the conventional layer. Some activation functions are ReLU, and some are max of 0 comma x, some are sigmoid curve. Okay, some are activation function at tan h volume, will have a dimension of 32 by 32 into 12. Okay, so pool layer, so there will be a pool layer, the layer which is periodically inserted with connect, and its main function to reduce the size of volume, which makes the computation fast memory, and it's also prevent overfitting. So two common types of poolings are max pooling and average pooling. If we use a max pools with 2 cross 2 filters and stride 2, the resultant volume will be of dimension 16, 16, and 2. Okay. So see, stride of 2. So you will be able to get 6, 8, 3, 4. Okay. Like this, basically. So fully connected layer, this layer is the regular neural network that takes the input from previous layer and compute the class scores and output of 1D array size equal to the number of classes. Okay, they might ask like what is a pooling, padding, filtering operations on CNN. So it is a commonly used periodically inserted a pooling layer in between the successive conv layer in ConvNet architecture. It is a function to progressively reduce the spatial size of representation to reduce the number of parameter computation in the network, and hence to also control overfitting. Pooling layer operates independently on every depth slice of the input and resize it spatially using the max operation. Alright, so there will be a max pooling, there will be average pooling. So our most common form in the pooling layer will be filters of 2 by 2 applied. The stride of 2 down samples with every depth slice in the input by 2 long both width and height, discarding 70% of activations. Every max operation would in this case be taking the max over the 4 numbers little 2 cross 2 region in same depth slice. So the depth dimensions remains unchanged. Okay, so like this basically. What is the evolution technique of CNN? It is a LexNet in 1998 after the 15 years lead groundbreaking models. ImageNet large scale visual recognition challenge, LexNet 2012 to the GoogleNet in the 2014 to ResNet in 2015 to Ensemble of previous models in 2016. Okay, in the last 2 years, no significant progress has been made, and the new models are an ensemble of previous groundbreaking models. All right, so these are the things you can just have a look. LexNet in 1998, what happened is seven-level convolution like network by Les Yun in 1998 that classifies the digits and several banks to recognize handwritten numbers on checks digitized in 732 by 32 pixel in grayscale input images. And then after AlexNet in 2012, AlexNet is considered to be first paper or model which rose to interest in CNNs when it won ImageNet challenge in the year 2012. It is a deep CNN trained on ImageNet and outperformed the entries that year. VGG in 2014. VGG was submitted in 2013. It became runner-up in the ImageNet contest in 2014. It's widely used a simple architecture compared to AlexNet. Okay, Google Net in 2014. In 2014, several great models was developed like VGG, but the winner of ImageNet contest was Google Net. Google Net proposed a model in inception modules like that include skipping connection in the network, forming a mini module, and this module is repeated throughout the network. ResNet in 2015. There are 152 layers in Microsoft ResNet. The author showed empirically that if you keep adding layers, the error rate should keep on decreasing in the context of plain nets. We are adding a few layers, resulting in the higher training and test errors. So next question they might ask like how to initialize biases in deep learning. It is possible to common initialize biases to zero since the random numbers in the weight provide the asymmetric breaking. For ReLU non-linearity, some people like to use some constant values such as 0.01 for all bias because it ensures that our LU units fires in the beginning. Therefore, obtain or propagate some gradient. However, it is unclear if this provides a consistent improvement. In fact, some results seem to indicate that this performs worst and it is commonly used to zero bias initialization. What is a learning rate? Learning rate controls how much we should adjust the weight concerning the loss gradient. Learning rates are randomly initialized. Lower the values of learning rates, lower will be the convergence of global minima. Okay, I hope this you have aware about the things sort of stuffs. If you are good at it, linear regression, folks, then all the algorithms that will help you very easy. Okay, higher the values of the learning rate will not allow the gradient descent to the converge. Okay, then, since our goal is to minimize the function cost to optimize value for weights, we run multiple iteration with different weights and calculate the cost to arrive at minimum cost. Okay, so these are the set of questions, folks. So let me know like you wanted to be a continue next series day 5 to should I complete this kind of a stuff? Comment down below in uh, section so I can make a video on this particular so that I can make a video on this regards. So I hope you got the clear cut idea about day 4 series. Basically day 4 day if if you want a day 5 kind of stuffs, let me know in comment down below, then I will recording this particular day 5 series. Then make sure that folks subscribe to the channel. Okay, if you want this kind of a content to be get notified and understanding what kind of a stuffs they might ask, this kind of questions I will be going to continue. Otherwise I will be thinking that uh, to make a content related to understanding the algorithms, I will be making that particularly. So thanks up till then, until the end you watch this particular video. I hope you enjoyed this particular video. So we will meet in the next video.